Welcome back, everybody. It is Monday, March 23rd. Hopefully, everybody is healthy and all is well. Last week, we started looking at how to multiply polynomials together. Um, and in section 5.6 and 5.7, the last two sections of chapter 5, we're going to look at special products in 5.6, and 5.7 will entertain how to divide polynomials. So 5.6 is entitled Special Products. And there's two main special products that we're going to be responsible for in this section. First of all, we have the special products of what are called conjugates. We say two binomials are conjugates of each other if they differ only by the sign in between their terms. So here's an example of two conjugate binomials. Notice the only difference between these binomials is just the sign in between the terms. One's a positive and the other one's a minus. Well, ladies and gentlemen, if you were to FOIL this all out and multiply this all out, you would discover that the two middle terms drop out, and that will always be the case when you multiply conjugate binomials. And so, the product of conjugate binomials is always going to be the difference between the square of the first term and the last term of the binomials. So this is a very important product. We will revisit this when we get into chapter 6, when we start factoring polynomials, which is the reverse operation of multiplying them together. Okay, the next special product is the square of a binomial. In general, if I have a binomial and I want to square the binomial, we know that to square anything means to take that something and multiply it by itself. So to square this binomial means to take a plus b and multiply it by a plus b. Well, instead of multiplying this all out and going through the FOIL algorithm that we looked at last week, this is just a pattern that we want to try to memorize, and this will be very helpful also for chapter 6. When you square a binomial, it's nothing more than the square of the first term, and in this case, it'll be plus, since we have a plus sign here, 2 times the first and last terms plus the last term squared. If we were squaring a minus b, this binomial, the product would be very similar, but there is a slight difference. The only difference is the sign. We would have the square of the first term minus 2 times the first times the last term plus the last term squared. So the square of a binomial, being familiar with these patterns are going to be very important in chapter 6 when it comes time to factoring trinomials. Okay. All right, well, let's just look at a couple here. Let's take this binomial x plus 10 and let's square it. Now, ladies and gentlemen, again, you could just multiply this out the long way, x plus 10 times x plus 10. But the idea in this section is to have us warm up to these patterns here and to try to remember these patterns. So notice I'm taking x plus 10 and I want to square it. So if you look at this pattern above here, a plus b squared, I'm going to put the pattern right below so that we can see how to tackle this. You've seen above that when you take a plus b and square it, that the product is going to be the first term squared plus 2 times the first times the last term plus the last term squared. Now we can follow right along here. Notice our a is, as far as this pattern is concerned, our a is really an x. And our b is really a 10. So wherever we see an a in this pattern, I'm going to replace a with x. So x squared plus 2 times x. And wherever I see a b in this pattern, I'm going to replace it with a 10. So we have 2 times a times b, or 2 times x times 10, plus 10 squared. Now cleaning this up, we're going to have x squared plus 2 times x times 10 is really 20x. And 10 times 10 at the end is 100. And there you go. So x squared plus 20x plus 100 would be the square of this binomial x plus 10. All right, let's try another one here. How about 4a plus 5 squared? Now to square this binomial, if we want to follow along strictly with this pattern here that was laid out above, our a term is really a 4a. Our b term is really a 5. So wherever we see a in this pattern, we replace a with 4a. And wherever we see a b in this pattern, we replace it with a 5. So therefore, here we go. We take our first term, which is 4a, we square it, plus 2 times a being 4a for this binomial, times b being 5 for this binomial, plus b squared, b being 5, so plus 5 squared. Now we clean this up. 4a times 4a is going to be 16a squared. 2 multiplied by 4a is 8a, and 8a multiplied by 5 is 40a. And at the end, 5 squared is 5 times 5, or 25. So there we have it. 16a squared plus 40a plus 25 is the square of this binomial 4a plus 5. Okay, we'll take 5m minus 3n, and then we'll try to square this. Again, following along our pattern here, the pattern we established on the previous page, if I take in general a binomial of the form a minus b and square it, I should get the square of the first term minus 2 times the first times the last term plus the last term squared. So following this pattern along here, my a, as far as this pattern is concerned, my a is really like a 5m. My b is really like the term 3n. So wherever we see an a in this pattern, I replace it with 5m. So a squared suggests I'm going to have 5m squared. Two times a is 2 times 5m, times b is times 3n, plus b squared, b being 3n, so we have 3n and we square it. So 5m minus 3n squared. 5m squared is 5m times 5m, which is 25m squared. Minus 2 times 5m times 3n. 2 times 5 is 10. 10 times 3 is 30. So the middle term is going to be negative 30mn. Plus 3n squared is 3n times 3n, which is 9n squared. And there you have it. That would be the square of this binomial. Again, we're just following the pattern that was established on the previous page. Okay, that pattern there. Okay. All right. To wrap this section up, let's look at multiplying some conjugate binomials together. We'll take a plus 6, and we'll try to multiply this by a minus 6. Now again, ladies and gentlemen, you're welcome to do the FOIL method and drag this out the long way. A times a negative 6, 6 times a, 6 times a negative 6. But there's a shortcut. Because these are conjugates of each other, these are called conjugates of each other. because again, the only difference between these binomials is a sign in between the terms. Because they're conjugates, we know that the product is always going to be the square of the first term minus the square of the last term of the binomials. So this is going to be nothing more than a squared minus 36. Shortcut. Try and multiply another pair of conjugate binomials, 10 minus x multiplied by 10 plus x. Since these are conjugate binomials, the product is going to be simply, again, the square of the first term of the binomials minus the square of the last terms of the binomials. 10 squared is 10 times 10, or 100. We have 100 minus x squared will be the product of these conjugate binomials. Let's look at 3x plus 5 multiplied by 3x minus 5. Here are some conjugate binomials. Again, you could multiply them out the long way using our FOIL algorithm we looked at last week. But the quicker way is to realize that these are conjugates of each other. And being the case, the product is going to be the square of the first term minus the square of the last term of the binomials. Upon further simplification, 3x squared is 3x times 3x, which is 9x squared, and 5 squared is 25. So 9x squared minus 25 would be the product of these conjugate binomials. Okay, we'll do one more here. Y squared plus 2 multiplied by y squared minus 2. These are conjugate binomials, and because they are, they adhere to the same pattern that we used on the ones above here. That's to say, we just square the first term minus, and then we square the last term of the binomial. Recall from previous work with rules of exponents, when we raise a power to a power, we multiply the exponents. So y squared squared is y to the 2 times 2 power, or y to the 4th power. And 2 squared is 2 times 2, or 4. And so, ladies and gentlemen, this would be the product of these conjugate binomials. So that concludes section 5.6, working with special products, the square of a binomial and the product of conjugate binomials. These examples should be enough to propel you towards having success with textbook homework and also activity problems that we'll be posting on Blackboard soon. So stay tuned. Take care.